program fully. In fact, now itself it crossed 50 or 60. In many industries, a group of people attending in the program. In Foundry Division, Srivarmudar and Ennur group of people are attending. So it shows the interest among the people to reduce the power consumption. So once again, I request Mr. Ravikumar to take us through this presentation. And before that, I request Vignesh to introduce Mr. Ravikumar to the forum. Thank you.
Thank you, Raman sir. So it gives me immense pleasure in introducing a very good member of the Indian foundry industry and also a very good friend of mine, Mr. Ravikumar. He is a graduate in Electronics and Instrumentation Engineering from Kakatiya Institute of Technology and Sciences, Warangal, Andhra Pradesh. Before joining in Inductotherm Group, he has worked as hand-holding person in AP Technology Services, Hyderabad. He joined in Inductotherm Group in the year 2000 as a service engineer and moved to sales in 2006. Currently, he is heading the sales of South India and East India regions of Inductotherm. Ravikumar sir has been responsible for the sales and marketing of induction furnaces of Southern and Eastern region of India. In recent years, Mr. Ravikumar made technical presentations in many foundries and steel clusters, namely NFD, Sauricon, IIFA, and customer technical training programs as well. So it is a great pleasure to have you with us, sir. The floor is now yours, Mr. Ravikumar.
Thank you very much, Mr. Vignesh. And
sir, just before you start, Mr. Nehal Mishra is requesting you to please switch off the camera, sir. Even I'm going to switch it off. We will only have the presentation. Sorry, Ravikumar, sir, you can go ahead.
Thank you very much, Mr. Vignesh and Raman sir, for your kind introduction. And also thank you very much for your entire team of IIF chapter for organizing the technical presentation. And I applaud your consistent efforts all along to serve the industry, the foundry industry. So, a small introduction. Okay, yeah. Sir, the topic is today's topic is this energy optimization induction melting practices. Before going to the presentation, I would like to give you a small synopsis about the requirement and the essentials of the energy conservation in the foundry industry. So the total the essence of this the presentation is to make you aware of that the variables and the factors that are influencing and contributing the power consumptions in induction furnaces. As induction furnace manufacturers, as a global the presence and across the world having manufacturing facilities with a huge R&D setups, Inductotherm has been consistently putting their efforts to minimize their energy consumption, the power losses, and to optimize the maximum energy benefits to the customers. So while in this process, there are other factors like operational parameters also contributing the energy consumption. So the combination of the three factors are the main assets of the today's topic. So I'm going to start my energy consumption, energy optimization induction melting furnaces presentation. So let me just brief you about what is the evolution of the coreless induction furnaces power supplies in last century. So since 1910 until today, the latest power supplies from spark gap converters to the latest IGBT voltage flat series inverters are in the evolutionary developments in the induction melting furnace power supplies. Before that, I would like to talk about. Pardon?
पण यावेळी आम्ही काय ते इंटरफेअर करणार नाही. तुम्ही ओके म्हणलं तर आम्ही उचलून घेणार, अदरवाईज नाही. त्यामध्ये
Sir, sorry, Ravikumar, sir. Yeah, you can go ahead.
Can I continue, sir?
Yeah, please, please.
Yeah. So before starting my presentation, I would like to just touch upon the induction principle so that our audience, especially mainly into the people who are from the plant maintenance electrical background, people can able to go through a overview about what is the induction principle. So the induction starts with a copper coil. As current flows through the coil, a magnetic field in and around the coil is produced. So the direction of the magnetic field depends on the direction of the alternating current flowing into that. Typically a 500, so the furnaces are operating at 500 cycles or 200 cycles. We have various frequency of furnace capacities. A typical 500 edge AC current will cause the magnetic field to switch 500 times a second. When melting scrap is placed in a changing magnetic field, voltage will be induced in the workpiece. Actually, this is called exactly a Faraday's law. So the induced voltage will result into the flow of the current. The current flowing through the workpiece will go into the opposite direction as the current in the coils. So as current flows through the medium, there will be some resistance to the movement of the flow of the current. That's flow of electrons or current. So this resistance exactly shows up the heat generation in the workpiece. This is called Joule heating effect. This is where exactly the induction melting principles commence. Okay, now let's going into typical energy utilization in the induction melting furnace. When we are applying about 100% power, a certain X kilowatt, there are some losses incurred from transformer till the melting of the till the coil in the form of transmission losses, power supply losses, conduction losses, convection losses, and radiation losses. So these losses are contributing about 20%, nearly about 20%. So each and every manufacturers have been putting their efforts to minimize these losses. So around 80% of the total energy, effective energy is being utilized in the induction furnace from the given 100% of the power. General questions from any foundry industry when we are going to talk. The first question is, how many kilowatts power consumption per ton will be consumed, or will I use it? The second question, where do you want to measure them? So generally, the power consumptions at the secondary of the transformer, the primary of the panel input. The high voltage input to the transformer, which is what you pay the power company for. The output of the inverter, which is what the manufacturer or kilowatt meter and computer system displays it. The third question is, we generally ask what is the temperature which you are going to melt up to this. There are different temperatures for different grade of metals. So from 1400 to 1650 across the foundry, from gray iron to the steel melting. So the temperature is going to overall power consumption this one. So that is the overall talk about the induction furnace. Now let us talk about the overall efficiency. What is that overall efficiency? That's the U cube formula. So what is U cube? The factors affecting the total efficiency. So equipment efficiency, that is called E1. So how it implies the electrical efficiency? The equipment efficiency is the utmost important to decide the efficiency of that equipment. And full power from the start. Lowest kWh per ton. More kgs per given kVA. lower harmonics, higher power factor throughout the irrespective of any power levels, highly reliable equipment, and the latest technologies. So these are the general features of any equipment which decides about the overall the efficiency from the OEMs, original equipment manufacturers, for contribution to decide the efficiency in that. Coming to the equipment efficiency is in our control. Coming to the scrap efficiency, which talks about, implies on scrap density, scrap size, clean scrap, short blaster scrap, rust-free scrap. And this is into the owner's, the plant, the owner's control. Coming to the third efficiency factor is operating efficiency. How the operators feeding the scrap into the furnace, that is the charging consistency. How often they take out the slag off. How good they are in determining the chemistry and the minimum holding time, and how fast they empty out the liquid metal from the furnace instead of holding into the liquid into the furnace. These are the main points which are contributing the overall the energy, the factors affecting their total efficiency. And last but not the least is the utilization. So I'm going to touch a few of these the heads, not totally. A slight brief about these points in my coming slides. So the equipment efficiency multiplies scrap efficiency and operating efficiency implies to the overall efficiency. That's called EQ. Let's take an example. If equipment efficiency is 98%, so as a OEM, we are manufacturing our equipment to the tune of 98%. And let us say scrap is beautiful scrap you are going to feed into the furnace, that's also with a 98% scrap. If operating efficiency goes down to 90%, the overall efficiency is 85%. Let us take one more example. Let us maintain the equipment efficiency as 98%. If the scrap efficiency goes down by 95% because of the borings contribution or the rusters contribution or the oversized contribution, whatever the reason, and maintaining the operating efficiency as it is, still it implies to the 83% lower efficiency. Let us take one more third case. If the scrap efficiency is 98% and operating efficiency remains same 90, if the equipment efficiency goes down to 90%, then the overall efficiency goes down to 79%. So this is proven to be the EQ, that is the overall efficiency is a combination of these three factors, which has been proven across the industries everywhere. So our goal is the higher the efficiency, the lower the kWh and vice versa. Selection of right combination is the key to maintain the overall efficiency. Let us talk. I'm going to talk about a few the heads from the each and every segment of the efficiency factors. So first is the equipment efficiency, E1. An optimum melt cycle with our voltage for series inverter is the energy required to heat T tons of metal from ambient to pouring temperature is Y units. Electrical losses are incurred in the system to deliver the required amount of energy to melt in the form of radiation, conduction, convection losses. So So the optimum melt cycle is one where the total energy required is delivering in the shortest time. The most efficient melting systems will deliver maximum kilowatts to the furnace from the start to finish. So we at Inductotherm assuring you that our furnaces can able to draw the power or deliver the power to the furnaces to the optimum levels. So the ideal sequence would be delivering a maximum kilowatt from start to finish. This is a very mandatory across any foundry industry. Second is the line power factor. So the power factor is very key nowadays everywhere. So the power factor should be proportional to the kilowatt rating in some of the companies. Whereas Inductotherm gives a constant power factor irrespective of any power levels. So that implies lower the kilowatt, lower the kVA. And that gives in some of the industry, in some of the states, they can avail a power factor incentive benefits, or they can avoid the penalties on the power factors, or they can minimize the power factor panels investments. And even within the available kVA, they can able to operate the maximum kilowatt even during the peak hours. There are various benefits from the line power factor. Many of our electrical fellow maintenance team must be aware of all these factors. So line input kVA. So this exactly implies the same thing, that when the power factor is constant, so the kV is exactly proportional to the kilowatt. So the kV will never ever demand due to the power factor when you are operating at a lower kilowatts on the induction furnace. The orange shows the Inductotherm's kVA requirement for given kilowatt. The blue shows the kVA requirement for in the other design manufacturers. Now, the buzzing word in Tamil Nadu especially is harmonics. Sooner or later, across India, the states may be going to impose these kind of harmonics. And so the harmonics are very, very essential to minimize from the furnace side, so that the overall harmonics at your electricity board you can minimize. Thereby you can avoid, one can avoid the penalties. For an instance, in Tamil Nadu, the department, the norms in the electricity board department is, if they don't maintain the harmonics, like the harmonic is in other word like the power factor. If they don't maintain the harmonics of current is 8% and voltage is 5%, they are the IEEE 500 norms or the Tamil Nadu Tangentco norms. If one fails to maintain those harmonics, they have to pay the penalty of about 15% on their total electricity board bill. For instance, if the EB bill in a month is about 1 crore, they have to pay about 15 lakhs. So the harmonics controlling in the overall plant is very, very, very essential. So what the harmonic levels in our Inductotherm's 24 pulse designs or in total THA, what we are talking about, are typically less than 6% on the current, and the voltage is less than about 5% or 4%. And individual voltages are even less than 3%, 2%. They are the much safer in line with the norms. Coming to the 12 pulse, the 12 pulse systems. So the harmonics about 7 to 7.5 or near to the 8%. Still our 12 pulse, with our 12 pulse designs, our harmonics are well within the tangent cone norms or on the border. So Inductotherm provides solution to mitigate the harmonics in tune with the tangent cone norms. This we have been consistently doing last about 6 to 7 years. So our latest all power supplies from 250 kilowatts or 175 kilowatt onwards, we can supply 12 pulse, 24 pulse designs. And the existing power supplies in entire Tamil Nadu or wherever, we can upgrade it to a 12 pulse, 24 pulse, wherever it is an essential necessity. So Inductotherm's latest high efficient power supplies and its furnace designs proving the utmost efficient norms in terms of highly energy efficient, advanced technologies and reliability. So our recent IGBT power supplies, the largest power supplies commissioned on tri-tracks, dual tracks, and very soon or later we are going to launch even multi-tracks of quad-tracks of IGBT power supplies, have surpassed our own benchmarks of the energy consumptions. So you can ping me on my personal phone to know about the benchmarks of the energy, the outputs, the consumption outputs on our latest power supplies. Thus about now coming to the scrap efficiency, now E2. So the main the point is the charge density. So in a typical melt cycle, the delay is being able to draw full power is a function of charge density. The initial charge should contain as much dense solid scrap or scrap that will pack densely as possible. It is possible to overcharge the furnace at the beginning. The first charge should not exceed 60% of furnace capacity and not be less than 40%. So the charge density is very essential feeding into the furnace to draw the full power from the beginning. At the same time, one should avoid the overcharging or above 60% of the furnace capacity. When you're talking about E2, the efficiency of this charge material or scrap, for mechanized charging system to operate smoothly, the charge material should have a dimensions less than 30% of the melt diameter. So generally the scrap densities, I'm just illustrating a small the scrap density of the various varieties of the scraps. Let's talk about the scrap quality. What is that? We talked about charge density. Now let's talk about scrap quality. The requirement is to melt 1000 kg of iron from 20 degrees to 1500 degrees. And energy required, this is called energy enthalpy. Plus the losses we need to add into that. The energy enthalpy is 374. So the first problem is that the scrap available in the open market is not pure iron or steel. It may be rusted. It may be covered in paint and rust. It may be covered in paint, rust, and have inorganic materials from 2 to 5% on it. So when, as you are aware of this, sometimes borings contains a lot of oil and inorganic, non-metallics items that contributes definitely an energy consumption. So all these non-metallics items will melt and become slag. The heat content of slag is generally considered to be twice that of iron at the same temperature. So I'm going to illustrate a small energy usage in the slag formation. The following is the heat content of a typical charged heat from ambient temperature to the pouring temperature. Let's talk about 1000 kg of iron with 5% slag. That means a 950 kg is the liquid metal out of 1000 kg being charged into the furnace. So 50 kg slag is generated from that. When you melt till the 1500 degrees, so the 950 kg requires about 355 kilowatt plus losses. And 50 kg of slag consumes almost double the power, that is about 37.4 kilowatt. So total required is 390. This is called heat content. Similarly, let's talk about a 10% slag melted in 1500 degrees temperature for 1000 kg. So where about 100 kg of slag is being generated. So for 900 kg, the power consumption is about 336.62, and 100 kg of slag consumes about 74.8. This thus implies to about 411 kilowatt. So what it demonstrates is 5% of slag requires about 10% more energy, and 10% of slag requires 20% more energy. So these are the factors that will increase the energy usage. Like when there are the foundries who short blast their returns when they're feeding back into the furnace, and they don't allow any rust or scrap into the furnace. But each and every uncleaned, rusted, sandy borings, non-metallics, inorganic contributes in the increasing in the consumption. To an extent, excessive fume extraction also. So where you have the canopy or the side dwarf fume extraction systems, sometimes even heel melting. So melting with the lower powers. So there are various factors are contributing into the higher power consumption, which we need to minimize so as to one can achieve with the utmost efficiency from the second U2 factor is called energy efficient, the scrap efficiency. Let us touch about the operating efficiency. So what are the factors in the E3? Mainly is the charging consistency. So an efficient way, it is an inefficient way to charging in the furnace, manual charging. So the optimum way to charge furnace is to use a vibratory feeder. When we are talking about what is the charging consistency, how fast the charge being feeding into the furnace, the way the furnace demands, or the rate at which the power is pumping into the furnace. So if you fail to do so, it ends up with higher power consumption and so many things. Similarly, the hoppers in a charging system should be sized based on the scrap density of material, which is consistently available in the commercial quantities. So the feed rate we talked about. And typically, we need to understand the importance of the lid covers. So we have been supplying the lid covers, vortex fume modes with the fume rings. So there is when furnace is operating with a lid cover on and lid cover off, the holding power is a different. Let us talk about a 5 ton capacity of induction furnace. When furnace is closed, when lid is closed, the typical power, the holding power requirement is about 150 kilowatt or 125 kilowatt to maintain the same 1500 degrees temperature. Whereas when lid is open, almost it is becoming a 2.5 times. Okay, so in order to avoid these radiation losses, the first and foremost, every furnace should have these lid covers. This covers not only saves the energy, at the same time it gives a safety point of view and also metallurgical point of view, and it acts as a barrier to avoid the contact between air and then the liquid metal surfaces. And sometimes it gives a very good safety factor and sputtling of the metals when any cold charge is being feeding into the induction furnaces. When cold charge comes contact with the liquid metal. So the other factor in the operation is the kilowatt rating of the power supply you purchase will establish the maximum melt rate you can achieve as a tons per hour. The rate at which you can pour metal from the furnace is governed by your utilization of the furnace. So total melt cycle minutes upon the power on melting minutes into 100 is the total utilization. So this is a variable from a plant to plant. in some of the industrial benchmark today we're talking is 75% is the utilization. Let us talk about a typical, before going to my next slide on the example. The utilization is very much essential in the any of the foundry industry. Let's talk about 1,000 kilowatt. A company, furnace A company can produce about 30 tons liquid metal per day, whereas B company is producing only 15-20 tons liquid metal per day. So why there is a variation is called on the utilization factor. So how much time you are pumping the power? Now, what is the utilization time or non-utilization time? We are going to talk about in our next slide. So when you're not melting, you still have to replace the energy lost through radiation and conductions. Let me show you a typical melt cycle sequence in any of the industry. It is an initial charge. Then it goes to the melting and charging about X time, maybe 1 hour or 45 minutes, depends on your kilowatt kg power density. It decides the melting and charging time. And generally opening cover, slag off, temperature dip and sample, closing cover, waiting for analysis, weighing your trim materials ferrolyze, opening cover, trim materials and closing cover, and superheat, and pouring empty. So this is a total melt cycle. Exactly only about 50% only the power is being pumped into the furnace. The rest of about 60-50% of the time, only the process is slag off, charging, or chemistry adjustment, or holding, pouring. So pour on melting upon total melt cycle into 100 is, as I talked about, and the percentage of utilization. To improve your utilization, you must reduce the time required by this part of the cycle. So which I'm talking about from green line to the vertical dotted line of the block. The faster you can empty the furnace, the better. So let us take one more example on the typical melt cycle of the sequencing. So open cover, slag off, temperature dip and sample, closing cover, and weighing for analysis, weighing trim material, and open cover for trim material again, and superheat. So if we can shorten your duration of the emptying of the metal, so this is exactly the time we can save here. That improves the total utilization. Thereby, you are utilizing your more, you are producing a more tonnage per given kVA to the plant. So the previous graph illustrated the melt cycle for one power supply with one furnace. Is generally we are talking about monotrack power supplies where you have the one power supply coupled with one furnace. And melt cycle sequencing in monotrack. Generally, let me talk about just I will show you that how these melt cycle sequencing in monotrack. So once the melting is done, it takes some time to emptying out. That is called total complete cycle. So 50%, let us talk about 50% is your melting, and 20% or 30% or 50% till to 50% is emptying of the liquid metal. Is a total is a one batch cycle. So in a day, maximum. This is how you can able to melt. The bottom, the inclined red one shows that the total productivity of the liquid metal throughput in each and every this one. So at 50% utilization, 8 tons can be poured every 92 minutes, or that is about 5.2 tons per hour. In order to improve the utilization, we have an options or dual tracks. Say wherever you are melting and pouring at one shot in the ladles, generally the dual tracks are not required. But in the process of in some of the foundries where the liquid metal contains liquid metal is required to supply throughout to the machine moldings or high pressure molding lines, the dual tracks and tri tracks are essential. So the purpose of this dual track tri tracks is when one furnace is on holding, pouring, and chemistry adjustment, deslagging, all this process, the entire power can be pumped into the second furnace where the actual melting takes place, and vice versa. So this is how we can almost the same kilowatt kg combination, we can improve almost 20 to 50% of the productivity within the same kilowatt and kg combinations. Similarly, at tri-track furnaces, that gives a very highly competitive edge over dual tracks and mono tracks. These are very much essential for the high pressure molding lines where you need a continuous metal throughout the time. Like every 20 minutes, you need the metal from the induction furnaces. So in this configuration, almost you can touch about 80 to 90% of the utilizations. So Inductotherm also supplying a quad-rack furnaces. They have been supplied in multiple places. They have been successfully running, and the requirement is going up now across the industries. So our quad-racks have been well proven in the industry to serve the liquid metal to high pressure molding lines. Now let me touch about the kV utilization. When I'm talking about kV utilization, as the recent developments increasing of the kVA charges. So power cost is a very important consideration, not only for new foundries, but also induction melting shops utilizing older furnaces. In study after study, batch melting systems have consistently proven to have the lowest electrical cost per ton when compared to the most modern medium frequency hill melting furnaces. Furthermore, Inductotherm develops, as I shown you in my previous slide. I talked about the dual tracks and multi tracks on the batch melting power supplies. Produces units that efficiently runs at 100% utilization rates. As a result, total overall kilowatt for maintaining the desired production levels are reduced, resulting in a much smaller induction systems and a lower electrical demand charges. So what it shows is this electrical demand is per given kVA, if you can able to produce the more tonnage with the latest new power supplies, definitely that gives a very good cost advantage in the overall OPEX, operational expenditures, to produce a ton of liquid metal in the foundries. I'm taking these 3 case studies, a small illustration, recent one of the exhibition when I met a couple of customers from different regions. So they said that they have got some XKVA, the contract demand, whereas they are happy with that the given contract demand, but they don't know how to reduce the contract demand. If they reduce their contract demand, they're in apprehension that the production may goes down. On contrary, what is happening exactly is I'm just going to show through 3 of case studies. Case A. Let's talk about a company company A. Contract demand is about 1,500 and furnace kilowatt is 1,000. Let's take a benchmark power factor about 0.99. So with the kVA into power factor is a kilowatt into hours, which implies to total the energy allotted to per day to that company A per day. So if the production of the total liquid metal per day is 20 tons, let's talk about 20 tons with the power consumption about 600. The total utilization is only at 34%. Plus the other auxiliary units have to be added into this to the furnace. Adding so maybe that is variable. That is a variable is industry to industry. So I'm not taking into the consideration, but 66% of the power is unutilized, which can be after using the auxiliary power, we can think of that, how to utilize that power, or we can surrender this power back to the grid, the department, so that you can each and every 100 kV or 1 kV per month. I think you are going to charge about 450 rupees. That is 100 kV is going to talk about a very huge amount. In a cumulative on a year basis, there's a huge amount. Similarly, case B, if I reduce the kVA, that means 250 kVA. Let's talk about 250 kVA. If you surrender the power to this one, into that means about nearly about 1 lakh something. 1 lakh is per month. So I'm not sure about level. You can cross verify at your end. The furnace kilowatt is 1000 and power factor is 0.99. The units allotted is 29,700 units since you are reducing your contract demand. So still you can able to produce the same tonnage like a KCA. So the utilization of your KVA goes up. It is about nearly 40%. Does it serve the purpose? No, absolutely no. Still we have the provision cushion to improve our utilization. So the case C is, let's talk about 1250 kilowatt, the 1250 kV contract demand. Still furnace kilowatt is 1000, power factor is unity, and the units allotted per day is 29,700. But the catch here is the production of the from the furnace is 30 tons. When you increase the production of to 30 tons, the utilization goes to 61%. So how this happens? Only because how effectively the utilization of the furnace with the dual tracks, multi tracks are being utilized, or tri tracks. So this exactly. So you will need to calculate producing more kgs per given kVA. Thereby you can reduce the minimum losses, minimum paying the minimum demand charges. So Inductotherm provides a solution to optimize and utilize the kVA among the loads, thus minimize monthly kVA charges. So I'm not going to talk today about our latest the PLC controls of iOptimizer Plus, Multiminders, Multiminders Plus. I'm definitely looking forward to talk about and touch about these all latest features in my, when I get an opportunity once again from the IIF Chennai chapter, then I'm going to talk definitely about those this one. But
Sir, we can see that some companies have attended from their team meetings. So thank you very much. You've attended as a group. Do we have any questions, sir? Sir, there is a question in the chat box, Ravikumar sir. How coil insulation is affecting on power utilization of power?
So, see, the periodic coil insulation, as per our preventive checklist, is to be maintained. In case generally the coil insulation may leads to some kind of the breakdowns, but definitely not to relate with any of the utilization of the power. But at the same time, the prescribed, the recommended the coil insulation to be maintained. That you can anyone has the question with respect to the particular this one, and we can share the details to you, or through you, or directly to them, so they can contact us.
Right, sir.
Sir, Ravikumar sir, Bengappa here.
Hi, sir. Hi. Good evening, sir.
Hi. So nice presentation.
Thank you very much, sir.
Sir, I have a question.
Yes, sir.
See, normally the capacity of furnace, see, normally even manufacturer also says same thing. See, you cannot melt the liquid metal above coil level. So if that is not considered, how a capacity of furnace can be decided? If it is 1 ton furnace, the total height will come to 1 ton liquid furnace. But the melting efficiency above coil will be always less. That is what we also feel. In that criteria, how will you substantiate this tonnage basis? I need 1 ton output in 1 ton furnace.
Exactly, sir. See, as I shown you in my first small animation that how this magnetic flux is being generated when you are applying and changing the electric current. So in any of the manufacturers, they design their furnace on by the H/D ratio, height versus the diameter. So thereby the maximum magnetic flux can be accommodated with the flux density so that the coupling will take place properly. So when you try to melt the metal where there is no magnetic flux, for example, the above the coil level, the whatever the freeboard has been provided is for the safety point of view, not for melting. But having a stray magnetic field, a 50% on the in the.
Sir, there is a question in the chat box, Ravikumar sir. How coil insulation is affecting on power utilization of power?
No, see the periodic coil insulation as per our preventive checklist is to be maintained. In case generally the coil insulation may leads to the some kind of the breakdowns, but definitely not to relate with any of the utilization of the power. But at the same time, the prescribed, the recommended the coil insulation to be maintained. That you can anyone has the question with respect to the particular this one, and we can share the details to you, or through you, or directly to them, so they can contact us.
Right, sir.
Sir, Ravikumar sir, Venkappa here.
Hi, sir. Hi.
Good
Good evening, sir.
Hi. So nice presentation.
Thank you very much, sir.
Sir, I have a question.
Yes, sir.
See, normally the capacity of furnace, see, normally even manufacturer also says same thing. See, you cannot melt the liquid metal above coil level. So if that is not considered, how a capacity of furnace can be decided? If it is 1 ton furnace, the total height will come to 1 ton liquid furnace. But the melting efficiency above coil will be always less. That is what we also feel. In that criteria, how will you substantiate this tonnage basis? I need 1 ton output in 1 ton furnace.
Exactly, sir. See, as I shown you in my first small animation that how this magnetic flux is being generated when you are applying and changing the electric current. So in any of the manufacturers, they design their furnace on by the H/D ratio, height versus the diameter. So thereby the maximum magnetic flux can be accommodated with the flux density so that the coupling will take place properly. So when you try to melt the metal where there is no magnetic flux, for example, the above the coil level, the whatever the freeboard has been provided is for the safety point of view, not for melting. But having a stray magnetic field, a 50% on the in the freeboard, still you can able to melt. That scrap which you are melting is in contact with the conduction, not definitely with the induction. So if you can try to limit a little or little above the coil level, you can save a kind of energy there. When you try to accommodate more and more even above the coil level in the till the top of the freeboard, then it ends up with a higher consumption. So hope I have answered your question.
Right, sir. The answer is right. But why don't you consider, while supplying us the equipment, consider only to the height of the coil above another 1.5 to 2 inch only. See, the constraint what I am talking is the capacity of the output of the furnace. See, if the height is top block is not considered, my output will be about 900 kg only. If it is 1 ton, almost 70 kg of metal will come less.
Okay.
How will be substantiated? No, why don't you make a design change itself?
In this one more, this one is as the lining eroses, the more liquid metal can be accommodated even to the coil levels. Sometimes if the lining, see, generally when we are talking about the specific gravity or density of the metal is 7.9 grams per inch cube or 7.2 for the iron, 109 grams per inch cube for iron and 118 grams for the steel. Generally that must be accommodating within the coil level. If you have any question on this, let me recheck about your cross section of the design and I can revert on this. But as the lining erodes, definitely when diameter increases, the height remains same, but the diameter increases of the melting, the bath diameter, where the more metal can be accommodated, must be accommodated in your furnace.
Ravikumar sir, we have a lot of questions on the chat box.
Yeah,
First question is how to encounter slag generation in lining on coreless induction furnace.
This is talking about it's a process, right? It's a process related question. Am I right?
Yeah, slag generation. Yes.
Slag generation. Oh, what is that question exactly? I cannot follow that.
No, how to encounter slag generation in lining on coreless induction furnace. Generally, slag generation will be there.
No, if they're talking about
scrap what the company is buying, that's all.
That is what, sir. Slag generation will happen.
And also to Banagappa sir, question, Ravikumar sir.
Yeah, when you're sorry, sir, can I?
Yeah. You can complete after that. I'll answer.
Yeah, yes, sir. Generally, what happens is when someone talks about the slag generation and how to get rid of slag generations, a ideal kilowatt kg combination with the right frequency, when you have got a proper the stirring index, if they can able to maintain it, whatever the slag is getting generated, that is, it will start, that tends to float on the liquid metal, thereby they can easily get rid of. If there is any kind of a mismatch in this, like a kilowatt kg and frequency combination, it ends up somewhere and it tends to stick to the walls sometimes. So thereby the melting diameter, the bath diameter gets reduced and they get lower liquid metals. That's one kind of this one. And as rightly said, the scrap quality is the scrap quality is the king. So one has to maintain to get rid of the to get rid of the slag at all from the furnace liquid metal.
Sir, KV sir, you can go ahead, sir.
Yeah. For Banagappa sir, question. Sir, you can alter your farmer size. Normally, the furnace manufacturer give the refractory lining thickness 4 inches. For example, in a 3-ton furnace, 100 to 120 mm they will give. Based on that, they will define the farmer and give. If you want to increase the capacity of furnace, you can reduce 1 inch and then improve that. For example, in one of the furnace, I have done that. So almost 20% of the liquid metal has gone up. 3-ton furnace, I am getting 3.2, 3.3 tons with the coil level. That is our risk. But furnace manufacturer will not recommend. It's our risk.
The risk is there, sir. That is why we don't recommend it. Normally, we follow only supplier drawing.
Yeah, that's right. But to get the output with the same furnace, I am getting 250 kg extra now. With the same furnace, same power, and I am getting energy advantage also.
No, as Ravikumar has mentioned, once the furnace lining get eroded, the capacity of output will definitely increase. See, what I was mentioning is, why don't we consider it as a tonnage? See, as long as, our workers, if you tell them 101 time, they will never catch up the point. They don't understand the power consumption criteria. They pull the metal. Whatever the number of times you tell, 10 times they do it. From 12th day, they start filling the furnace. So to overcome this, I was asking Ravikumar to think of some design factor wherein full is always full. So
that's right.
We should come up with some technology. That is what I am advising Mr. Ravikumar, because Ravikumar is master in furnace. Inductotherm.
Correct. From them only we learned. See, what I am doing from the first lining itself, I change the furnace diameter. Yeah. And the first heat onwards, I am taking the more than the capacity of the furnace.
By altering the farmer. Yeah,
altering the farmer size.
So there is a question in the chat box.
Yeah, next question. I'll just move on.
Thank
sir.
you, thank you, KV sir, and thank you, Benkappu sir, and
thank you,
thank you,
sir.
KV sir, helping me and giving the.
No. Whatever I learned from you, I'm sharing.
No, it's my. Thank you very much. And the question, Vijesh sir, would you like to talk about
I'll ask the next question, sir. Regarding safety aspects available in Inductotherm furnaces, you can just mention they're asking, sir. Safety aspects available in Inductotherm furnaces.
So generally, the safety aspect is the GLD. So the GLD, which is available with our system, is highly sensitive, and it will take care of the. It will prevent it definitely from the metals running out. There's much more. If that can be prevented, that saves almost 95% of the human safety point of view. Coming to the equipment safety, if we're talking about equipment and component safety, we have been providing all the instrumentation in terms of the temperature, flow, pressure, and the advanced controls of our HMIs, and to safeguard our electrical components from the higher fluctuations. Have been inbuilt features of our systems to say taking care of the safety point of view. In case of they would like to have any kind of literature from our end, I can share through you a soft copy of the safety points. You can share it to all your members, sir.
Surely, sir. Sir, the next question is, what is the recommended furnace lining thickness from Inductotherm?
Before going to the lining thickness, typically it varies from the furnace capacity to furnace capacity, and he's not very specific about what capacity he's talking about. But I don't have any ready-made answer also for this. But I can say one thing. There are 3 points. One is the coil installation and the coil coating. The right coil coating with the minimum thickness as recommended by Inductotherm is to be maintained. If they go with the higher the thickness of the coil coating, that leads to the insufficient cooling to the refractory. In turns, that may war sintered, and it may become a crystal, and the possibility chances of the metal runs out. So here what we can say is the coil insulation, coil coating, and the refractory thickness with the proper specified by OEMs, and the proper sintering. That is much more important. So that has to be maintained. So our latest furnaces, we are offering to our customers with Optimisation plus controllers. There is an inbuilt feature called automatic sintering on the time-based or the temperature-based. So one can program the system, the program teach, so that the controller will take the control of the sintering automatically. It runs based on the your sequence. Thus ensures that the refractory safety point.
Sir, there is one more question where he's asking, slag generation has increased the power consumption. What do we do?
See, as we talked about, every 1 kg of slag consumes double the power of the scrap, iron and steel. We talked about, let us say about 600 units is the power consumption for a ton of liquid metal. A slag consumes about 1,200 units. So the lesser that means definitely the proper cleaning of the scrap, the rust-free scrap, short blast of scrap has to be charged into the furnace. That is only the payout.
Right. The next one is recommended PPE or LOTO. I think he's asking for running the furnace. What is the PPE? Yeah?
I don't know what is the technology of these abbreviations of PPE and LOTO.
PPE is personal protective equipment, I think, sir. That is to be worn while running the furnace. For that question,
yeah.
Mr. Senthil, if you want, you can.
Yeah, that is logout, tagout, anything, logout, tagout like that.
Oh, logout, tagout, okay. Logout, tagout, and PPE you are asking.
And PPE, yes.
Right.
Like a furnace, a person is working under the furnace. In hydraulic,
Yeah.
it is up and down.
So, anything, Ravikumar sir?
So he's talking about the PPE and the LOTO. What is that LOTO, sir? What is that about?
Lockout, tagout, sir.
Mhm.
A person is working under induction furnace and it is hydraulically up and down operation. You have to lock
Okay.
it down.
Okay.
You put the lock and you put some information on it.
Okay. Yeah. So I can try to share this information through email or through phone. I don't have ready-made answer for this, so let me revert on this.
Right, sir. What would be your recommendation for charging? Be very loose or irregularly shaped scrap? Recommendation for charging, they are asking, sir.
No, the very loose is not advisable at all. That's what we have been recommending, that high dense to the 60% of the furnace level is recommended feeding to the furnace, but it should be continuous. Okay, so the scrap, I cannot ask you that to give the smaller size scrap to feeding to the furnace, but generally when you're feeding through a vibro feeders, to roll out in a proper way, the scrap has to be very, very smaller size. So the fundamental and the principle of the scrap into the furnace is it can be loose, but it should be smaller size, medium size, but it should be a little high dense scrap.
Sir, I think you answered this partially. After heat completion, the slag is sticking to the wall. How to get rid of it? I think you already answered it.
Exactly, I said I need to check that why these are sticking to the wall, and what is if they see the stirring factor. What we are talking is that means kilowatt is proportional to the stirring of the liquid metal, and the kg is inversely proportional, and the frequency is inversely proportional. So if someone asks about 1 ton liquid metal of the 1 ton of the furnace capacity with the required kilowatt combination and frequency, we decide to give that so that the optimum this stirring takes place. When the optimum stirring and adequate stirring takes place in the furnace, generally the slag will not stick to the walls of the furnace. If the metal is stand still, the metal is not moving. Okay, the depth of penetration is lower. That implies to the metal standstill, and in turns the slag is going to stick to the walls or in the bottom. Generally, this happens in the aluminum melting, where this draws Al2O3 aluminum oxides stick to the walls. So we generally recommending a different kind of frequencies with high stirring indexes. Similarly, for iron melting, typical iron meltings, we are recommending to go with the higher stirring factors. Generally, for steel melting, we recommend a moderate stirring. Okay. So for generally in iron melting, we are giving. So if he is talking about the slag sticking, definitely it is from the gray iron foundry or cast iron for the SG foundry. So I need to check that exactly the kilowatt kg frequency combination. Thereby I can give the answer on that.
Sir, next question from Mr. Anjaneya Prasad. Can you please give the average utilization of kVA in the foundry industry in general?
Sir, I recommend that you should go with the till about 80% plus, because when generally in industry where you are paying higher kVA charges, you are taking X kVA, but you are using only 50% of that kVA and in terms of the units. So 50% you are paying more kVA to the department. So there are two interventions required here. One is a human intervention. Second is automatically taking to the control. So the automation part, that human intervention, what they used to do is they fix up some demand controller at this one. Whenever they're coming near to that kVA, that buzz the alarming the operator to reduce the power. But it is now the continuous process, and it is very, very alerting process of the operators, and very tedious also. It is not recommendable. So what we are talking is there are many PLC controllers available there are many manufacturers in the market who are supplying the PLC controllers. So the PLC controller, what it does is that takes the complete control of your maximum demand and sharing the power among your auxiliaries as well as the furnaces. So the only control is in the furnace, not in your auxiliary, because your auxiliaries whatever the power is required in your auxiliary, they will take automatically. The remaining power, it goes into the induction furnace. So the control takes in the induction furnace. Inductotherm has been supplying, the control is called Master Power Controller, MPC. We have got standalone MPC, or it is a part of our iOptimizer Plus that take care of that is taking care of this kVA utilization. So with that, I can assure you that you can utilize up to about 80-85%. Typical, or let me take one example of steel plants. Generally, steel plants load factor today, they're talking about 95%. If you take it about a Maharashtra giving an incentive of on load factor incentives, that means per given kVA with allotted units, if they can consume above 90-95%, they will get huge benefits, rebates, and paybacks. So utilization of the kVA is very essential at this juncture. So please, you can contact us directly to improve your kVA above 80-85% with the standard norms, and we can maintain up to even 92, 93, 95%.
Right, sir.
So this is Suresh Kumar. Any
Yes, sir.
online temperature controller is there for my? It is effective.
Sir, online temperature, are you talking about the liquid metal monitoring
Fine.
temperature?
Yes.
So see, online temperature is not possible because see, only thing is you need to go with an infrared temperature meters, but the problem is that the slag, which is preventing to sense the exact temperature of the liquid metal on the top layer. So but the only thing is once you slag off, we are not doing it, but the suppliers, like renowned suppliers in the market, they have been supplying infrared, the wireless
The gun kind of things.
gun type. Yes.
Because it will give huge energy saving. If you have any recommendation, you can try. No?
So what is the furnace capacity you were talking about, sir? Which one?
8 tons, sir. 8 tons, sir.
Okay. From which company you belongs to, say?
So this is Ashok Lane Foundation, Sri Paramuthur, sir.
So what I can talk is, what I can offer you is, see that you're rightly talking about the energy. We have got MMD plus. We can talk. I can let me talk about MMD plus. How it serves the purpose. See, there are two controls. One is the iOptimizer, the energy optimizer. So what we can do is we can supply a low-end automation which can take the control of your the energy consumption in the furnace by pumping about 600 or 650 units. Thereby it starts counting down at the initial of the heat starts. By completing that 650 or 630 units, the metal should be ready, or else the power will be taken into the control of the iOptimizer, either to switch off the furnace or get taken into the holding power. That ensures that you are not crossing your given or rationalized allotted units. That is one way of controlling the power consumption, and at the same time that can definitely controls your temperature, so prevent the superheating of the temperature. The second is we are coming out with a good proposal is called MMD plus. What it does is the load cells in the furnace gives the load payment to the computer. So once you dip the temperature at about 1400 or 1380 degrees, or at the time of the sampling, the computer calculates for a given the weight and at the X temperature, the set temperature, as let's say about another 100 degrees to be superheated, the computer will take the control and it superheats to the set temperature about 1500, 1550, and automatically it stops the furnace. So by doing so, these two controls, one is iOptimizer, second is MMD plus, we can control yours or prevent the superheating of the temperatures. Hope I have answered your question, sir.
Okay, thank you, sir.
Sir, there is one. There are actually a lot more questions. There is a question from Mr. Mohammed. In 5-ton induction furnace for SGI and melting, how many linings once coil service is required?
But I'm not the right person to talk about this coin illustration. So I can contact our regional service head, our service managers in Chennai office, so that I can share Mr. Ravikumar number or Mr. Ethirajan's number so that they are the right people to give about. Generally, as for the benchmark of the industry, generally they go with the once in a year or twice in a year, the coil installations. Irrespective of the furnace capacity, they do it twice or once in a year. It depends on your operation point of view.
Right. There is one question from Mr. V.K. Raman, our vice chairman of the chapter. Unit per ton of liquid metal, any benchmark value?
So today, our latest power supplies, we are talking about 490 units are the benchmark figures for the iron melting to melt about 1500 degrees temperatures. But if you are adding any slag into that, every 1% of slag contributes about 11 units or 10 units that need to be added to the 490. We have some of the installations where we have touched even 480, 475 units also. It depends on the operational parameters. As I told you that at the end of the day, those three factors are the key. If you can maintain the good scrap quality and good operational efficiency, and with the right equipment, because the right equipment efficiency is constant. There's no any variable. It doesn't change day to day. Okay. Once we supply the furnace, that is throughout the efficiency of the equipment remains same. The only variables into the the efficiency of the equipment may vary from manufacturer to manufacturer. Otherwise, as far as we is concerned, Inductotherm is supplying the utmost highly efficient equipment that is constant. The rest of the two you need to take care. If you can take care of these three, the power consumptions are guaranteed or less than 500 units for iron melting.
Right, sir. Then next question is, what should be the ideal per ton consumption for SG iron and gray iron for 1 metric ton furnace?
So generally, I can give you one thing is a ton of 100 degrees raise of temperature per ton of liquid metal will consume generally typically about 35 units. So generally, according to me, the temperature difference between the cast iron to the SG is about, let's say, talk about 50. That means the 50 degrees would require additional 17 to 18 units additional consumption. Okay. So if the all other three parameters remain same as a U cube factor. Okay. Again, I always talk about U cube factor. If the U cube factor remains same for with the complete this one, the only the superheat of additional 50 degrees would consume about 17 to 18 units consumption.
Right, sir. I think that is all the questions we have. We have received.
I need to add one more point in the gray iron and SG iron. Generally, what happens is in the process. For gray iron, most of the times in some of the foundries, when they are making larger castings, they will try to pour the entire metal at one shot. Thereby, they don't hold the metal in the furnace. Whereas coming to the SG iron, when you're treating in the ladles, there is some stipulated time to empty out that metal. So they cannot empty out the entire metal from the furnace. They take into the batches, like 1 ton of metal is taken into 3 of 300 kg or 2 of 500 kg. Thus, that is delaying in the that is delaying the furnace, still remaining in the induction furnace, and the holding power is additional power is pumped into the furnace to hold that metal is definitely incur additional consumption apart from that 17 units.
Sir, I think Mr. B.R. Garg has raised his hand. You have any questions, Mr. Garg?
So he's my counterpart. He's my colleague in Delhi. So
Okay.
thank you, Garg.
Right, sir. And we've got a lot of wishes in the chat box. Thank you, Benakappa, sir. Thank you, Mr. Sanjay Agarwal. Thank you, Mr. Pradeep. And thank you, A.D. Deshpande, sir. And BTI team also for your thanks. So if there are any further questions, we can answer it or we can go ahead with the vote of thanks. So we will go ahead with the vote of thanks. So Friends, we have indeed had a very interesting and informative webinar today on the topic of energy optimization in induction furnaces. We are sure the contents of the talk had a lot of takeaways for all the audience. We'd like to thank Mr. P. Ravikumar, Senior Manager Sales, Inductotherm India, for taking his time off his busy schedule and making us rich with knowledge. Further, we'd like to thank all the members who joined us for this talk. We are really happy that you joined us today. Thank you for acknowledging our WhatsApp and mail invitations and joining us. I'm sure you had a wonderful learning experience, and thank you for joining us on time and being such a wonderful audience. At one point in time, we had around 95 attendees today. It is we are really encouraged in conducting such. Yes, sir.
It is 95 plus, because
95
many
plus, yeah.
areas, group of people attending.
Yeah, correct. Like in Ashok Leyland, I think 10 people are sitting in the training hall and attending. Yes, sir.
Just also a group of people attending.
So I think more than 100 people have attended today and have gained knowledge from us. So it is very much encouraging to us. We from Chennai chapter will be conducting many more such interesting webinars and seminars, both online and in our IIF office. So we'll be sharing information with you soon. So looking forward to you seeing you in our upcoming programs. Thank you very much for joining us. And a special thanks to Ravikumar, sir. Thank you, sir.
Thank you very much, sir.
Thank you, Ravikumar, sir. Thank you.
Thank you very much, sir. So before concluding that, let me thank you once again to the entire team of the Chennai IIF chapter. So, Mr. Shaktivel Tinokrusu, sir, Chairman. Mr. V.K. Raman, sir, Vice Chairman. Mr. Vignesh Ramanan, Honorable Secretary. Mr. Senthil Kumar, Honorary Treasurer. Thank you very much for giving me the opportunity. And I really applaud that for your continuous support to the industry, the way you have been conducting. And I look forward to participate once again, definitely, if I get a chance to come out with any kind of opportunity in the coming time. Thank you very much once again, sir. Thank you.
Thank you, sir.
Thank
you so much.
Thank you, sir. Thank you.
Thank you. And thanks to everyone who's participated. Thank you very much.
Thank you all.